Ladies and gentlemen, boys and girls, welcome to another exciting video of algebra. This is lesson 5.6. Essential question, how do I graph inequalities in two variables? Well, as Miss Johnson always says carefully, Miss Oberly says accurately, and Mr. Friel likes to say, like a boss. Alright, here are your learning targets. I got some feedback that the game show voice got annoying, so I will try my hardest not to do it, although that is very hard for me. Number one, I can graph linear inequalities on the coordinate plane. Number two, I can solve inequalities by graphing. Write both those down. You might want to pause now. When would we ever use this? You don't have to write this down, but one way you might want to use this if you're ever budgeting so you don't spend too much money. For example, maybe you're planning a trip and you want to make a certain amount of money and you're selling multiple different items. Well, each item has a different coefficient, a different cost, and you have to figure out how much you will sell in total to make at least, this is the at least symbol, the amount of money you want. Key vocabulary, you're going to want to know these three terms and write them down. The first one is boundary and half plane. The boundary is defined by the equation, and it's the line that cuts the coordinate grid in half. So that's the boundary. On each side of the boundary are half planes. There's two types of half planes. The first type is a closed half plane. In this diagram we see a closed half plane because it is a solid line. You will get a solid line anytime that you have the inequality symbol with the equal sign underneath. So either less than or equal to or greater than or equal to is called a closed half plane because the line is solid and closes in the shading you will do. Obviously, the other type is an open half plane, and that does not have the equal sign underneath. When you do not have that, you're going to make a dotted line. Key concepts. This is right out of your book. There's three key concepts. Graph the boundary. Use a solid line when the inequality contains greater than or equal to, less than or equal to, or greater than or equal to. And it's a dashed line if it does not have the equal bar underneath. You will always use a test point to determine which half plane you should shade in. The shading says which solutions will work. Step 3, shade the half plane that contains all the solutions, any solution that works. Here's examples when you have a solid line and a dotted line. You will notice in this equation here, we have an equal bar, so the line is solid. In this one, we do not have the equal bar on the inequality, so the line is dotted. Here are two examples of test points. From the origin, I go over 2 for x and up 2, and that's a test point. If I put these into this ordered pair into my equation, I would put a 2 and add it to 4 multiplied by 2. Well, 2 plus 8 is 10, which is greater than or equal to 2. Over here I chose a point that's in the shaded region, and I'm trying to see if it will work. I put the negative 2 where the x is, and that would be 4 multiplied by a negative 2, which would get me a negative 8. The 2 is my y, I put that here. 2 multiplied by 2 is 4. I subtract a negative 8, which is like adding, and I get 12, which is greater than 6. So I know that I shaded the correct side. You always shade where the solutions work. Example number 1. 3x minus y is less than 2. The first thing you should do is pretend that this is an equation. This will be more familiar to you. In this equation, it looks like it's in standard form. You could solve and graph this from standard form by finding your x and y intercepts. That's one choice. So graph either by finding the x and y intercepts or by changing the equation into slope-intercept form. So the first way we're going to do this is finding the intercepts. So if I put 0 in for x up here, I would have 3 multiplied by 0, which would give me 0. What would I need to subtract from 0 to get a positive 2? Well, in order to get a positive 2, y would have to be negative 2. So I take my points and I put x is 0 and y is negative 2. Next I find my other intercept, my x-intercept, by replacing y with 0. Well, 3 times what number minus 0 is 2? Well, in order to multiply 3 and get 2, you have to multiply by the reciprocal, which is 2/3. So in this case, x is going to be 2/3, not the easiest to graph. So if y is 0 and x is 2/3, it's going to be about right there. In which case I could graph this line. But we're going to show you a way that you're more familiar with, which is the slope-intercept method. So in slope-intercept, you would take your equation and you would isolate the y. So here you can see I added the y to both sides, so the y came over to this side, which made it positive. Next, I subtracted 2 from both sides, which got my y isolated. Now, it's easier, you're more familiar with seeing the y on the other side, so I just flip the 2 because they're equal, and we have y equals 3x minus 2. I graph this by first graphing my y-intercept, which is already there, which I had, and then I use my slope. So my slope is 3, so I go up 1, 2, 3, and over 1 point. You'll see my 3 points line up pretty nicely here. Okay, next, I'm going to take my line and I'm going to put it on the graph. You'll see it's dotted, and the reason it's a dotted line is because it doesn't have the equal bar. So the next thing I have to decide is which side to the solution is. So I'm going to try to put in 0, 0 and see what happens. I put a 0 in for x and a 0 in for y. 3 multiplied by 0 minus 0. When I solve that, I get 0 minus 0, which is less than 2. So I put my 0 here, and this is a true statement. 0 is less than 2. In this case, I'm going to have to do some shading. Since 0 is a solution, I'm going to shade everything to that side, including the 0. So I'm going to shade everything on this side. I don't know how picky your teacher will be about how much shading you do, but you want it to be pretty well shaded in, I think. Doesn't have to be perfect. Example 2. X plus 5y is less than or equal to 10. Now in this case, we're going to follow the same protocol. We're going to pretend that this is an equation, and we have x plus 5y equals 10. We also have two choices. We can either graph the intercepts, or we can do slope-intercept form. Remember to pause as you need. So the first way I'm going to do it is with the y-intercept, with the finding the intercepts. So I find my intercepts and I put an x equal to 0. Now if I put a 0 here, it's pretty apparent that y is going to be 2 because 5 multiplied by 2 is 10. So that one's pretty easy. So I'm going to put my x is 0 and my y is 2. And likewise, if I put a 0 here for my y, my x would have to be 10. So I put a 0 for y and my x is 10. I think this is a 10 grid. Let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Now I can make my line straight through those points. But let's see what happens if you do slope-intercept. Okay, so first we want to isolate the y. We move the x to the opposite side. In order to do that, we subtract it. Next, we divide by the coefficient in front of y, which is 5. And we get a slope of negative 1/5 and a y-intercept of 2. So I put my y-intercept, which is obviously in the same place, and then I do my slope. So I'm going to go down 1 and over 5. 1, 2, 3, 4, 5. And you'll see that that lines up perfectly so we can place our point in. So we can place our line in, I should say. So I grab my line and I'm going to put that right in there. Now you'll see that I have a solid line this time, and the reason I have a solid line is because I have the equal bar. Now I'm going to test my point. I'm going to test 0, 0. I put 0, 0 in and I see if it works. So x is 0 and y is 0. Well, if I put those in, I'll see that 0 plus 5 multiplied by 0, and 0 plus 0 is less than or equal to 10. Okay, so now it's my shading time. So since 0, 0 worked, I know that I'm going to shade on that side again. So I'm going to shade everything on that side. And it's harder to do it on here than on paper with your pencil. Okay, here's your third and final example for today. We have 3x plus 5 is less than 14. Think for a second what's different about this equation than the last two. Well, you should have noticed that we only have one variable. If there's only one variable, you're just going to use the symbolic method and you are going to solve for x. So as we do that, we notice that we change it to an equation. Next, we isolate x by subtracting 5 from both sides. And finally, we divide by 3 and we get x is equal to 3. Well, how do you graph that? What that means is x is always 3. So we go over 1, 2, 3 and put a point. Now your x, no matter what your y is always 3. So if y was 1, x would be 3. If y was 2, x would still be 3. What you're going to notice here is you have a vertical line. So we're going to take our line and we're going to put it on here, make it vertical, and I'm going to extend it a little bit. You always put arrows on the line. They should go up and down. And why is it dotted? Well, remember, there's no bar here, so it has to be dotted. So let's test the point. So I put 0, 0 in. It does not always have to be 0, 0. You can try many different points, but 0, 0 is very easy. So if I put a 0 in here, I have 3 multiplied by 0, which is 0. And I add that to 5, and that is less than 14. So any number that's less than 14. So since 0 works, we know that we shade in the direction of that solution. So everything on this side will be shaded. All right. Reminders. If 0, 0 is on the line itself, it does not make a good test point. Use a different test point that is not on the line. If the test point fails, that means you shade the other side of the line. It would be a good idea to test points on both sides until you feel really confident. And please remember,